Lesson 9.2 is going to focus on operations with complex numbers. So our learning target is I can perform arithmetic operations with complex numbers. Therefore, we can add, subtract, multiply, and divide. So when we say we're going to do operations with complex numbers, a complex number is a number that can be expressed in the form a plus bi, where a and b are real numbers, and then I is obviously our imaginary unit. So first we're going to start with adding complex numbers. So when we're adding complex numbers, all we're doing, we can just think of I as a variable. So I, if we were to think of it as x, we would combine our like terms. So we would combine our terms with x's, and then we'd combine our constants, our numbers together. So here we would combine -3 and 7. We would add them together. So we would have -3 plus 7 is going to give us -4. And then we would add together our imaginary numbers here. So we have 5i and -6i. So if we have 5i's plus -6i's, then we have -1i. So for the second one, we have -2 times the quantity 7 minus I plus 6i. So just like if we were doing this with any numbers, first thing we have to do when we have a number outside parentheses is always distribute that number in. So if I take -2 times 7, I have -14. -2 times a -1i is going to give me a +2i. And then plus 6i. So if I look at my first number here, I have a -14, and that's not going to combine with anything because we have no other numbers for that to go with. So I just have -14. And then I have 2i plus 6i, so I have 8i. So -14 plus 8i would be my final answer. So the next operation would be subtracting complex numbers. So it's going to be the same concept as if we're adding them together. However, we're just taking away our piece here. So we have 6 minus 4i minus the quantity 2 plus 8i. So when I'm subtracting, it's like I have to distribute in a -1. So if I distribute that in, it's like I'm changing the sign. So this becomes positive. If I distribute in a -1, it's -1 times 2, which becomes -2. And -1 times 8i becomes a -8i. So now I have addition, and I just combine my like terms. So I would take 6 and combine that with -2. So 6 plus -2 is going to give me 4. And then I have -4i plus -8i, which gives me a -12i. So 4 minus 12i is my answer. It's my complex number, which was like that a plus bi. So I have 4 minus 12i. Go ahead, look at that second example, copy that down in your notes, and give it a try. Pause the video, work it out in your notes, and then hit play to find out the answer. So if I'm going ahead and I'm solving this, first thing I have to do is distribute into my parentheses. So I have -3 times 6i and -2. So I'm going to rewrite this. I have -5 plus 7i minus 18i plus 6. So I have -5 and 6. So -5 plus 6 is 1. And then 7i minus 18i gives me a -11i. So hopefully you got 1 minus 11i. Now looking at multiplying complex numbers. So it's that same concept we were going through before, so you're just distributing it in. The one thing we're going to have to make sure we pay attention to is when we talked about imaginary numbers. If we have I squared, we have -1. So anytime we have an I squared, we're going to have to change that to a -1 and combine any of our like terms. So if we look at our first one here, we have 2i times 5 plus 5i. So we have 2i and we just have to distribute that in. So I have 2i times 5, which gives me 10i. And then 2i times 5i, I multiply the two real numbers, 2 times 5, which is 10. And then I have I times I, which is I squared. But we just said I squared is -1, so I can take this I squared and I can replace it with a -1. So I have 10i plus 10 times -1. So I have 10i minus 10, because 10 times -1 is -10. However, when we write complex numbers, we always want to write our number out in front before the piece that has our imaginary unit here. So, because we have a plus bi, so I would write this as -10 plus 10i. So if I'm going ahead and looking at the second example here, I have -2i squared. So when I have an exponent on the outside of parentheses, I'm distributing that exponent in, and I'm going to multiply those powers there. So this becomes -2 squared and I squared. So breaking this down, -2 squared is 4, because -2 times -2 is 4. And I squared is -1. So 4 times -1, my final answer here is just -4. And my last set of multiplying examples here. So we could have a number multiplied into a set of parentheses. We could have to distribute in an exponent, or we can have two binomials here that we're multiplying together. And when we do that, we're going to distribute the first one into the second one. You might remember FOIL, first, inner, outer, last. I like to just distribute in. So I'm going to take 4 and I'm going to multiply it by both terms here. So I have 4 times 2, which is 8, and 4 times -5i, so I have -20i. Then I'm going to take my second term and distribute that in. So I have 3i times 2 and 3i times -5i. So 3i times 2 is 6i. And 3i times -5i, I have -15. And 2i's is I squared. So break this down. I have 8. That can't combine with anything. -20i and 6i is going to give me a -14i. And then -15, and my I squared is the same as -1. So I have 8 minus 14i. -15 times -1 is a positive 15. And my two numbers can get combined, so I have 8 plus 15, which is going to give me 23, minus 14i as my final answer, multiplying out these two binomials. So I take my first term and I distribute it in, my second term distribute it in, and then simplify. The biggest thing to remember is I squared equals -1. Now our final example, 1 minus 6i squared. Hopefully we know what to do here, because from unit 3, anytime we have a binomial squared, we have to write it out twice. So I have 1 minus 6i times 1 minus 6i. And then from here I do what I did on the previous example. I multiply 1 in and -6i. So if I multiply in 1, I have 1 times 1 and 1 times -6i. So I have 1 minus 6i. If I multiply in -6i, I I have negative 6i times 1, which is negative 6i. And negative 6i times negative 6i, which is positive 36i squared. So now I want to go through and simplify. So I have 1 minus, I can combine my i's, 12i plus 36, and I squared is the same as negative 1. So I have 1 minus 12i minus 36, and now I can combine my numbers. So 1 minus 36 gives me a negative 35, and I have minus 12i. So negative 5 minus 12i. So big thing to remember here is if I have a binomial squared, I have to write it out twice before I distribute.